Hello and welcome to this edition of Marvell's Follow the Wire video series. In this video, we're going to talk about Remote Direct Memory Access, or RDMA protocols for Ethernet I/O adapters in HPE ProLiant, Apollo, and HPE Synergy servers. Let's start by explaining what RDMA is. With normal Ethernet, TCP/IP packet processing is done within the driver, the OS kernel, and the information is presented to the software application. With RDMA, all the processing is offloaded within the adapter, and the OS kernel is bypassed by the adapter and communicates directly with the memory resources that are being used by the application. Eliminating access by the kernel reduces the time it takes to process each packet, which ultimately reduces the latency of each I/O transaction. Now, let's look at a picture of how RDMA changes the data and I/O processing within the server. So with the standard Ethernet, here's how the data is transported from one server to another. The data flows from the server on the left, from memory to the CPU, then to the adapter and onto the network. And the server on the right receives the data with the adapter, processes it in the CPU, and then pushes to memory to access by the application. Now let's look at enabling RDMA. Now what you see here is that the data flows from the memory directly to the adapter in the first server and onto the network. When the data is received from the network by the adapter in the second server on the right, processing takes place directly to the memory and the application. In both cases, you're bypassing the CPU and the servers. The result is transactions happen faster and I/O latency is reduced. Now, what you may not be aware of is that there are two different types of RDMA protocols to choose from, and the bad news is they're not interoperable. RDMA over Converged Ethernet, or RoCE, is the predominant RDMA protocol that people talk about and use today. First available with InfiniBand for high-performance compute environments, it's now able to run on converged or lossless Ethernet networks. RoCE typically provides adapter latency in the 1 microsecond range at the adapter. Now, RoCE delivers a great low latency performance, but there are challenges with limited scalability due to the complexity and congestion challenges associated with having to deploy a lossless Ethernet environment. These are the same challenges we faced back in the days of trying to deploy fiber channel over Ethernet. Now, another RDMA protocol available today is iWARP. Now, there's no fancy acronym, it's just iWARP. And this runs on standard TCP/IP stacks, leveraging TCP congestion management. And that makes it the easiest by far to implement. Just enable it on the adapter and run on the existing network. From a latency perspective, this ranges in the 6 to 10 microsecond range at the adapter, but it's still well below that of a standard NIC and way below the overall latency end-to-end when you include all the switches, applications, memory, and everything else. Because it works on standard TCP/IP stack, iWARP delivers good low latency performance at scale as a result. Now this slide's another way to look at RDMA protocols that are available. The size of the building kind of reflects the scalability of the protocol. RoCE is the least scalable because it requires a lossless Ethernet network. This means added complexity of technologies like data center bridging, priority flow control, and more. And standard RoCE v2 is usually only scalable across 1 or 2 hops maybe. To improve scalability, things like data center quantized congestion notification, or DCQCN, were essentially invented by people like Microsoft for their Azure environment, where they do in fact scale RoCE v2 to thousands of nodes. However, this isn't something that the typical enterprise customer would likely implement due to the added complexity and the network engineering and administration resources required to keep an environment like that up and running. iWARP provides the most scalable approach because it runs on standard TCP/IP and uses standard TCP/IP flow control. No changes required to your existing network to support using iWARP. The reality is that both RoCE and iWARP will have their sweet spots. When latency is the #1 factor, RoCE is a great choice. When ease of integration or scalability are key considerations along with low latency, iWARP becomes a good choice. Here's a diagram of the various places that we see customers looking to deploy RDMA-enabled NICs. First is the clustered server or hyperconverged infrastructure HCI environments. Low latency networking using either RoCE or iWARP enabled NICs are supported today by the major OS vendors in this clustered environment. Linux and Microsoft both support RoCE and iWARP today, and VMware supports RoCE RDMA and is adding iWARP in the future. Now, because iWARP takes advantage of TCP/IP congestion management and it's highly scalable, we will see customers use iWARP to connect servers to cloud applications for low latency connectivity. Additionally, as storage array vendors build up NVMe native storage arrays, some customers will want to deploy low latency RoCE networking for use in storage traffic in the SAN. When Ethernet and RDMA is required in the SAN, RoCE is the likely choice because it's the most established RDMA protocol. Storage people like technologies that have established track records, for example, Fibre Channel, and it's also available from multiple vendors. The good news is that no matter what RDMA protocol is required, the Marvell FastLinQ RDMA-enabled adapters support both RoCE and iWARP, a feature we call Universal RDMA. At Marvell, we believe that choice for HPE customers is a good thing, and that's why our Ethernet engineers created Universal RDMA. This is the ability for a single adapter to run either RoCE or iWARP, or if needed, both on the same adapter. Universal RDMA is available on any of the HPE adapters based on the Marvell FastLinQ 41000 or the 45000 series adapters. You buy a single adapter and the RDMA choice is yours. There's no vendor lock-in, and you can change your implementation as your needs change without having to rip and replace the adapter from the server. RDMA is becoming more prevalent and in some cases required with popular enterprise applications and operating systems. Examples include cloud and big data applications like Hadoop and SAP HANA. RDMA can be used in HCI and software-defined operating systems like VMware 6.5 and 6.7, which supported RoCE RDMA with para-virtualized RDMA for VM to VM low latency traffic. And VMware 7.0 supports VMFS running over RDMA across the entire VMware cluster. Microsoft Azure Stack HCI, well, it supports SMB Direct over fabrics with RDMA, where iWARP is recommended and RoCE is supported as well. You'll see customers benefit from RDMA with SQL or Oracle database applications and for any latency-sensitive applications. And finally, customers looking to deploy NVMe over fabrics on an Ethernet network where RDMA is a hard and fast requirement, NVMe over RoCE is available in Linux today and will be available in VMware 7, Update 1, and onwards. It'll also be available with Microsoft down the road. Marvell FastLinQ is the only adapter family available today that supports both RoCE and iWARP on the same adapter. RoCE and iWARP can run concurrently on a dual port adapter. You can't run both on the same port, but port 0 can run RoCE and port 1 can run iWARP or vice versa. The table here shows HPE adapters that support FastLinQ Universal RDMA. Here's the portfolio list for Marvell FastLinQ 10 and 25 gig adapters for HPE, ProLiant, and Apollo Gen 10 Plus servers. These support Universal RDMA and are ideal for future-proofing Gen 10 Plus rack and tower servers to connect to 10 gig or, more importantly, 10 and 25 gig connectivity with low latency. So here's your call to action. As usual, follow the wire and discuss I/O requirements with your clients in every server and storage opportunity. Investigate their needs for low latency Ethernet networking and recommend HPE adapters with Universal RDMA. If you need help, engage with the Marvell I/O experts on our HPE team. We're here to help you. You can email us at the address shown here, or you can get contact information on our HPE specific microsite at www.marvell.com/HPE. This is your one-stop shop for HPE and Marvell information and utilities. And finally, sign up to our Follow the Wire rewards program at www.ftwrewards4hpe.com and reward yourself when you're learning about I/O technology from HPE and Marvell or engaging with the HPE Marvell team. Well, that's it for this Follow the Wire video. I hope you found the information somewhat useful. Please give us your feedback at hpesolutions@marvell.com. I want to thank you for your time and attention, and I'll talk to you on our next Follow the Wire video. Have yourself a wonderful rest of your day.